Hi guys, so I'm going to walk you through your Year 9 winter exam paper and show you some of the techniques you can use to gain a few more marks as you go through the paper. And I'm going to start off by highlighting all the bits of information that I think are important. I call it active reading, and it means you make less mistakes. So starts off, it says 3 energy sources I use to generate electricity, and I'm given list A, and here's list A. So I'm making the connection. Statements about the energy sources used to generate electricity are given in list B, and again here's list B. Draw one line from each energy source in the list to a statement about the energy source in list B. So just double check, I've got 3 marks, so it means there's going to be 1 mark for each point, and so they're going to be looking for geothermal. So I will always kind of work through and give myself a bit of a short list, so I won't leap in. So uses energy from falling water, uses energy from inside the earth, well that to me is a maybe, is unpredictable. I don't think geothermal is unpredictable because it's underground, produces dangerous waste. So I'm going to go with my first connection being this one. Hydroelectric, well, it's got the word hydro in it, and I know that hydro means something to do with water. And the only one to do with water is this one, using falling water. And nuclear, well, nuclear is unpredictable, it could explode, but actually that's very, very rare. In reality, it's actually scientists can predict when it's going to stop working, but it does definitely produce dangerous waste. So I'm going to go with those answers. I've got my 3 marks, moving on. The world's biggest offshore wind farm, offshore might be quite important, built at the Kent coast. The fact is Kent doesn't really matter too much, you're not expected to know where Kent is, even though it is my hometown. Started generating electricity in September 2010. One advantage of using the wind to generate electricity is it's a renewable energy resource. Give one other advantage of using the wind to generate electricity. So the most common mistake here is to refer to something already given in this diagram. So it says it's offshore. It says that it is renewable. So what else can we add into that one? Well, we're looking for things like what about carbon dioxide reduction. So I'm going to say there's no, sorry, wrong button. There is no CO2. So there's no CO2 reduction. So that's a good thing. It's 1 mark, so I think that that's enough. Name one other renewable energy source used to generate electricity. So once again, it does refer to me the fact it's one other than wind. I'm sure you can all name a few other renewable ones. So I'm going to go with solar power. All right, again, it's worth 1 mark. Now onto a graph, and this is where we can pick up some skills. The graph shows how wind speed affects power output. So it already tells me what they are measuring and what they're changing from a large wind turbine. Let's just make sure I get my head around the graph before I read the question. So I've got the power output in kilowatts. You might not know what kilowatts is, but it doesn't particularly matter at the moment. Just accept that more power must be a good thing. And wind speed in meters per second. What's the maximum possible output from this wind turbine? So we're after, let's have a little look then. So what's the maximum? It's really important, very difficult to have a tablet, is that we very carefully read off a graph. So I'm looking really carefully along this line here. And absolutely really should be using a ruler to do this, as I can't particularly do it easily on a tablet. Because the examiner's tolerance is really usually about half of one of these small squares, and they will give you very little either way. Be careful that you always include the units, so it is 3,000 kilowatts. So always look for those units because we've already identified those units there. Next bit says, read the first part of this newspaper article. For the past 2 weeks, most of the UK's wind turbines have been generating less than 1/6 of their maximum power. To avoid power cuts in the future, some experts said that more nuclear power stations need to be built to provide a reliable source of energy. Okay, I'm looking at that word reliable. Use the graph to explain why the power output from the wind turbines was less than 1/6 of the maximum. So it's after this word explain. Now, if I'm honest, this question doesn't immediately say to me what it means, but I'm going to use a graph to see if I can gain some more information. So 1/6 of the power, well, that must be 1/6 of 3,000, or if you can't do that in your head, maybe you can do 1/6 of 30, which was 6, so 600. So 600 is just here. So I'm going to draw straight along again, as neat as I can with a ruler. And I'm going to draw straight down here. And I'm going to come up with a speed of, I count my little squares, I've got 10 squares, so each one's worth 0.5, so 6.5. So there's a wind speed of 6.5 meters per second. So I'm just going to double check I'm happy with that. So possibly it's most of the UK's wind turbines being operated at less than 1/6 of the maximum power. To avoid major power cuts in the future, some experts said nuclear power stations need to be built. Right. So why was it 1/6? Because the wind speed was below 6 meters per second. So now up here, I've realised my line is a little bit wonky, so that's 6. Should be on the 6 meters down here. Again, this is why it's so important to use a ruler, so it should be 6 meters per second just there. But I would lose that mark had I been really sloppy like I've done in my answer, had I come out of 6.5 meters per second. It's worth 2 marks. So what am I looking for my second mark? So not at maximum power. So I've developed, I've given a point and I've explained it. Can I develop that any further? Well, that means how much power was it given? Well, I've already shown it on my graph. It was given 500 kilowatts. And the examiner will take your answer from your graph as well, knowing that you've worked out 500 kilowatts. Okay, then it says, having more nuclear power stations help avoid power cuts in the future. Which of these 2 reasons explain why? A small amount of nuclear fuel generates a large amount of electricity. Well, it does say nuclear, so I'm happy with that. The radioactive waste produced must be stored for many years. That's true, but let's think about what the question's actually asking you, and it says, which of these explain why? And the question's about power cuts. So actually that's irrelevant. Nuclear power stations do not depend on the weather to generate electricity. Well, that is relevant, so it is 1 and 3. So again, be careful you don't leap into tick all correct statements. Okay, next question is about waves, and I know some of you have only just covered waves, but that's okay. So waves can come in 2 types, longitudinal or transverse. Quick little revision recap. A longitudinal wave looks like a series of lines and then getting squashed out. Imagine a slinky where you bunch it up and it springs out and you get those compressions. Well, that's a longitudinal wave. The same way a sound wave pushes out from your voice box. A transverse wave, you tend to see going up and down, and that tends to be like light waves. Right. So the question says, describe the differences between longitudinal waves and transverse waves, and it's worth 3 marks. So I'm looking for 3 paired statements. I can't make 3 points, it's going to be 3 paired statements. So one of the things examiners are always looking for is this detailed bit of knowledge about the idea of which way the energy goes, which happens to be the same in both, and which way they oscillate. That means which way they vibrate. And that's our first difference. So transverse waves oscillate. Now I don't want to say up and down because the wave doesn't have to go up and down, it can go left to right. So I'm going to say at right angles to the direction of travel. Sorry, my writing's awful on this tablet. And I've got to keep it paired. So I'm going to say whereas. I'm just going to put LW for longitudinal waves, but I'd like you to write it out in full. Oscillate. And the word again I'm looking for, again, the same way, means parallel. Okay. In fact, that answer would give you all 3 points because examiners are looking for key words in their answer. And you've just given the fact that they oscillate. Oh, don't do that. That they oscillate, being one of them. You've given the angles parallel or at right angles or perpendicular. And you have given to the direction of travel or energy transfer. So that gives you a really high level answer. And that's all 3 marks. Next one, it says, radio waves are electromagnetic waves. Now, in your exam, we gave you a little bit of extra help and we said that radio waves are a type of light wave. Describe how they're different from sound waves. Well, actually, this is very, very similar to the previous question, but we want to include those keywords. So radio waves are a type of transverse waves because they're a type of light. Whereas sound waves are longitudinal. Remember, it's 4 marks, so I would aim to make pairs of points. What else can we say? Well, they radio waves travel because they're light at the speed of light. And radio waves, if you look at them on a wave, they will tend to have greater frequencies than other types of waves, than sound waves. So again, we can say they have higher frequencies. Because I'm using the word higher, this is key, it's a difference. And lastly, one special feature of radio waves is they can go through a vacuum, they can go through space. But, and I always want to add it in, but sound waves cannot. You might have heard the phrase, no one can hear you scream in space. And each time I've put paired answers, just a little recap, I've put radio waves are transverse, whereas sound waves are longitudinal, it's a paired point. Radio waves travel at the speed of light, whereas sound waves don't. Radio waves have higher frequencies, and radio waves can go through vacuums, but sound waves cannot. So I've always talked about these pairs, and this is so important to gaining more marks. Right, next section is on to biology. And so this time we've got a food diagram, food web, and let's just have a little look at it first of all. So starting at the bottom, we've got algae. You might not have heard of algae, but probably seen the green stuff growing somewhere. Krill, probably less people have heard of it, but it's a food web, so at the end of the day, the krill are eating algae, which are then in turn eaten by the fish or by the squid. The squid also eat the fish, and the elephant seal eats both, leopard seal eats the fish, and finally the toothed whale is at the top of the food chain. So I've got in my mind what this diagram is showing before I leap into the questions. Okay, what name is given to all organisms together in an ecosystem? Well, as is typical, this is not actually about that food web. In most of your questions, they will give you a bit of context and then talk about some general things, and then finally go back to that diagram. So there are no clues for this one here. You just need to know that organisms living together in an ecosystem is a community. And remember, if we combine that with all the abiotic factors, the rain, the humidity, we'll then call it an ecosystem. So it's just one of those ones you need to learn. Give the name of one secondary consumer in the diagram above. Well, the clue word here is secondary. And I'm sure you heard the word maybe consume or consumption. So it's a second thing to eat something. What is a second thing to eat something up here? Well, it's not the krill, so the fish or the squid would have been absolutely fine for that one. Algae can photosynthesize. Again, you will come across this briefly in year 7 and 8. That means they use the sunlight to turn that into food, like glucose. Which word describes the algae in this food web? Well, they're reminding you that at the start of a food web, it's always the producer. But if we're not sure, let's just look at the other options. Are they consuming stuff? Well, no, they're not eating anything. Are they a predator? Look at the diagram if you're not sure. Okay, we're not eating anything, so it can't be a predator. Are they prey? So really down to two different things, and it turns out prey or producer, but always the start of a food chain starts with producers, and that's some form of plant in some way, and algae are a type of plant, if not a little bit different. Okay, next one's explain why most algae in the are found near the surface of a sea and not at greater depths. And well, this is about how they are able to gain more light, if any, at the surface, so they can photosynthesize faster. This is a question we removed from the exam, so I'm going to skip past this a little bit. Okay, the next one says some animals are adapted to survive in very cold conditions, such as the Arctic. Doesn't matter if you know where the Arctic is, but hopefully you do. Explain, so give me reasons how adaptations of Arctic animals help them to survive in cold conditions. So we're looking at how many marks. Now in your exam we made this 4 marks. So I need 4 points about how they are adapted to survive. And it doesn't give me any examples, that's great, so I could pick an example. So let's pick the most obvious one, a polar bear. Think about what you know about a polar bear. I'll draw one for you. So that's a polar bear. Not sure if bears have tails. So what can we say about it? Well, first of all, it's got, you think that it's got really thick fur. And it's got a very thick blubber. That means a layer of fat. You could equally say layer of fat. So it's got those. It's a slightly harder one. Okay, we might use the idea of like surface area to volume ratio. The idea that organisms can be either very pancake shaped and very thin and flat, or they can be much more rotund and sausage shaped. I don't know, they don't really look like pancakes and sausages. And so the phrase we might use is it has a small surface area to volume ratio. What that means is it is much more round, it has much more insides relative to its outsides. Okay, it has less surface area. Remember this question, it says explain. So I need to give reasons for these things. What are the benefits of each of these? Well, the thick fur means there is less heat loss. So I'm now explaining each point. Thick blubber, well, I don't want to say the same thing again. I could say less heat loss, that is true, but what else might it do? Well, polar bears will go months without eating, so it is to provide a food store. And small surface area to volume ratio, how does that help? Also, I'm going to have to go with it. It's also going to help reduce heat loss. But where I can, I'm going to try and avoid saying the same things. Anything else I might want to add in? Well, let's just recheck the question. It says to survive in very cold conditions such as the Arctic. Well, it is just this general survival. So what do polar bears do? Or let's think about other organisms as well. Well, you might go that they're walking across the snow, they might also have large feet. Why? To move more easily. It'd be very hard to walk across the snow on stilts. But by thinking about an animal, I'm helping myself structure my answer, and I shouldn't limit myself to one answer. Right, next one says, students use quadrats to estimate the population of dandelion plants. Let's get estimate on a field. Describe how the quadrats should be used to estimate the number of dandelion plants in a field. So I told you all those key points twice, and I've said estimate. So we'll talk about sampling. So what's the process called? Well, we're going to use something called random sampling. Now that is the activity when you go outside and you all run around and no one really pays attention and you get really bored and really cold and you stare at some plants and wonder what's going on. It's that activity, that lesson that everyone absolutely loves, especially science teachers who seem to get really excited by it. But a little recap. in case you've forgotten. Quite often we might want to compare two fields. Okay, this one's got a sheep in it. And yes, it does look like my polar bear. And I want to see what the effect is, or how many plants are on each. So I'm going to put some little plants in my field. And so what I want to do is I want to go and measure how many plants there are, but I don't want to be out there all day because you know how much you enjoy it. I want to just take a few samples and be able to calculate how many are there rather than do the whole field. So I will take one of those square grids and I'll place it down a few times in my field, and I can then count how many daisies in or dandelions in this quadrat, and I can use that to work out mathematically how many is in the whole field. I could do the same for another field and compare it to one that the sheep are eating. This question doesn't ask about sheep, so I'm going to leave that out. So it's called random sampling. So what am I going to do? I'm going to place the quadrat down. Now I've put myself a little diagram. It wasn't totally pointless. I can now help structure my answer. So place quadrat. Now how many do I want to do? Well, a good number is always about 10 samples. That would help me have a nice accurate answer. Then what do I want to do? Well, I need to kind of think about where I place it. So I've already kind of mentioned randomly. So how do I place it randomly? I could use lots of people would say throw it, but that's actually a really, really bad answer. It's a much better answer is to say that I'll use a random number generator on my calculator. And what I can do is mentally divide my field up into different squares, right, and give them a number, and I can use that random number generator to decide which square I will sample. Then what do I want to do? Well, the hard bit is how to do it mathematically. I've got to count them. So I count my dandelions, and then what do I do to work out how many dandelions there are? Well, there's a formula I can use, and that is the area of the field over the area of the quadrat and then times by the number of dandelions. Obviously, it might not always be dandelions. So if I could think about it, if I fit 10 quadrats in my field and there's 2 dandelions in each quadrat, it's going to be 20 dandelions in my whole field. Right, good. I've written bullet points and I've got 4 points to match my 4 marks available. Right. So this question here, again, we took this out of the exam, but just so we know how to do it for future. It says what the field measures. It says how big the quadrats are. And it says they've got a mean number of dandelions per quadrat. Estimate the population of dandelions on the field. Well, I'm going to use that same formula. Area of the field. So first one needs to know what that is in my head. So just a quick bit of mental maths, not using a calculator. So we'll just do 45. So 40 times 145, and that's 5,800. And then I'm going to divide that by my quadrats. Well, it's 1/4 of a metre. Those who are quick could also multiply your answer by 4. So let's do that one again. 5,800 divided by 0.25 equals 23,200. That means in this field I could fit 23,200 quadrats. Now, I wonder when you can take a sample of 10 and not test the entire field. It'd take me forever. And then in each square I've got roughly half a dandelion. So I'm just going to multiply that answer by 0.42. Again, we just work that step out. 23,200 times by 0.42. So I'm expecting a number about half, so 9,744. Again, it's 2 marks, so make sure you can do these maths questions. If you can't do this, definitely worth some practice because it will come up again and again. Okay, so we skip this question because we didn't do it. Last biology question says there are many biotic and abiotic factors that affect the growth of plants. Are the factors biotic or abiotic? Well, people often forget this, but the word bio means biological. So it's either biological or not biological. Disease, definitely biological. Herbivores, animals that eat stuff, definitely biological. Temperature, no. And water, no. So just think about what it means in biological. Right, again, we didn't include these couple of questions, thanks. Right, so we're on to our chemistry questions now. And so this time it's about atoms and atomic structure. Last little bit, well done for listening. So an argon atom, well, don't know if you can't remember what argon is, although you've always got your periodic table to hand, and you can look it up and it's in that far column. It says it was represented by the numbers 40 and 18. So just a reminder what that means. The bottom number always means number of protons. And the top number equals protons plus neutrons, all the bits that make up the nucleus. Why they don't give you an extra number, who knows, but it probably will get very, very messy in the periodic table. So what does number 40 represent? Well, the protons plus neutrons is the atomic mass. Please use the word mass in this context, okay, not weight, because it's a slightly different meaning. How many protons does an atom of argon have? Well, let's go back. It tells me that in numbers, that's what the 18 means. So that's easy. How many neutrons does it have? Hang on, does it tell me that? No, it doesn't tell me that, but that's a little bit of maths. If I know that 40 is protons and neutrons, and 18 is protons only, I'm doing 40 take away 40, take away 18 equals 22. You're probably there quicker than me. All right, the next one shows the energy levels, or also what you would have called shells most often, in a neon atom. And there's not much there at the moment. And it says neon atom has 10 electrons. Complete the diagram above to show the electronic structure of a neon atom. People are really good at this. Just remember the rules. It goes 2 in the first shell, and then we can have up to 8 in the next shell. And I always go around the clock. 1, 2, 3, 4, 5, 6, 7, 8. So I've now got 10 in total, and that matches. So I'm happy with that. The most common mistake will be to get carried away by counting and end up with 10 in the outside shell, which would be wrong. The nucleus of a neon atom has a charge. What is the charge? Well, if you think about it, inside the atom are lots of protons, and around the outside of a neon atom are lots of electrons, and they are positive and negative charges, but the center has a positive charge. A neon atom has 10 protons, 10 electrons, and 10 neutrons. Why is there no overall, and this is the key word, charge on a neon atom? So this time we're looking at the fact that the atom overall is balanced, and so how do we word it correctly? Well, the best way is to say there is an equal number of protons and electrons. So it's really messy writing, isn't it? That's 1 point, but there's 2 marks available. So I just want to think, what else can I say? Well, I'm going to say that the positive cancels the negative. Now I've got my 2 points. There's 2 different types of neon atom. What are these different types of atom called? Okay, that's a little bit tougher. Compounds, let's go through it bit by bit. That's when you have 2 different things and you join them together, 2 different elements, you join them together. Ions, well, I've come across ions. That's when you have an atom like sodium and it's got an electron in the outside shell and you steal it away to make a new chemical. So it's not an ion. Isotopes, maybe. Molecules, no, because molecules are when you join 2 atoms together. So it is isotopes, and that's when they have different numbers of neutrons in the nucleus, but the same number of protons. Neon is a gas. The states of matter can be shown by a simple particle model. Draw 1 line from each state of matter to the correct particle model. Hopefully we can all do this. So gas, liquid, and solid. Take note how they draw on these diagrams. So if you have to draw your own diagrams later, you know exactly what they're looking for. That there are small gaps in the liquid and then nothing is touching in the gas. And then on to our final question. So it says quite a bit of information here, so let's highlight. In 1866, John Newlands produced an early version of the periodic table. Part of Newland's periodic table is shown below. So remember, lots of people have had a go at trying to make a periodic table, and only Mendeleev was successful in getting it right. So Newland's periodic table arranged all the known elements. Why does it say known? Because they didn't know about them all beforehand. Into columns in order of their atomic weight. Newland's was trying to show a pattern by putting the elements into columns. Iron does not fit the pattern in column 7. Give it a reason why. So let's find iron first of all. So there's iron. There's my iron there, it's going to be drawn around. So what do we know? So let's look at the rest of 7. Well, we've got S for sulfur. And we've got O for oxygen, or oxygen is a gas, sulfur. If not sure, let's have a look at our own periodic table and dig that out. And you'll see that oxygen and sulfur are both on the non-metals, whereas iron, hope you know, is a metal. So there's my first difference, but I've had to use my periodic table to have a look at that. So iron's a metal. That's going to be one answer, and it is only worth 1 mark, so I think that's good enough for that one. In 1869, Dmitry Mendeleev produced his version of the periodic table. So that's the guy who did it for real. Why did Mendeleev leave gaps for the undiscovered elements in his periodic table? It's been an odd question, but let's go back to all the information. And what we've set up here is, we mentioned this idea of known elements. There's already a little clue that might just jog your memory that actually not everything had been discovered. So it's about discovery. And then once you discover them, what can you do with them? Well, he can make sure that the right elements fit the pattern. So by leaving gaps, it meant he wasn't forced to put the wrong element in the wrong group, like Newland's did. Newland's and Mendeleev placed the... Where's my highlights gone? Newland's and Mendeleev placed the elements in the order of atomic weight. Complete the sentence. The modern periodic table places the elements in order of, well, if you're not sure, go back and get your periodic table and have a look, and look at the numbers that go up, and you'll notice that the smaller number is the one that goes up, and as we've already mentioned earlier on, the smaller number is the atomic number. Gosh. So the atomic number is what they go up in order of. And in a way, by saying that they've been placed in weight and then asking you a question, kind of infers that atomic number is going to be the right answer. So lastly, lithium, sodium, and potassium are all in group 1 of the modern periodic table. Explain why. Well, one of the key features of all these elements, if you look at them, they all have 1 electron in their outside shell. What is the significance of that? Well, if they all have 1 electron, they all react in the same way. For example, all of them will react with water and produce a violent reaction, albeit a little bit different for each one. Right, guys, well done for listening. Hopefully you picked up a few little bits there, or learned a few little bits of knowledge. So now I want you to go to a 10-mark challenge on the back of your paper and just write down a couple of little bits that you've taken out of this review of your exam, just to help you improve. And by doing this all the time, we can improve our exam technique. Well done.